Okay, let's take a look at symmetry, and while we're at it, we will also talk about even and odd functions. The word functions is one of the key differences here. So first off, symmetry, right? Think of anything that if you folded along a line, it would be a mirror image, like a butterfly, for instance. And rather than memorizing these rules, I think it's important to understand what's going on. So I went ahead and in orange in this upper corner here, wrote how to test for symmetry. But really, if you know, what it would look like, then I think it's a little more obvious of why you would do that. So if something is symmetric about the x-axis, I'm going to draw a generic function to the right over here. So if we're talking about the x, right, here's the x-axis. So we may have some function drawn in blue here that looks like this then, right? So the line of symmetry is along this x-axis. Whoa, that should not have happened. There we go. Along this x-axis here. If I were to fold it in half, right, if I were to look along that line, the top and the bottom would match up. Well, as you move along each of those points, what's true about them is the fact that each y value, right, say we're at some x, I don't know, 2 or whatever, and say this is 2, 1, for instance, the x would remain the same, but the y changes to a negative, right? Up here I'm at 2, 1. Down here I'm at 2, negative 1. And that's true all along this graph. So as we move, right, the x stays the same, but the y becomes negative, and we have both of those. So I wrote this y with negative y. If you replace those and you get the same thing, then it's symmetric about the x-axis. And this function I drew would look something like, or it's not a function, I'm sorry. This relation I drew, x equals y squared, let's say, right? If I substituted 1 for y, I would get x equals 1. But if I substituted negative 1 for y, I would still get x equals 1. So even if I substitute a negative y in for that y, it looks identical to how we started because that negative squared is positive. Okay, so that's what we are talking about, replace y with negative y. And then one thing to note here, if it is symmetric about the x-axis, it will not be a function because it fails the vertical line test, right? Like if I drew this vertical line, it crosses more than once, that is not a function. So the other two, though, the y, if it's symmetric about the y-axis, I'm out of room up there, but that's okay. I'm going to draw it here and erase. Suppose y equals x squared. Right, y equals x squared. That is symmetric about the y, and it is a function. If I drew this line, each of these points would fold to this other side, right? So each x, we'll just say this is like 2 and this is 4. The y's now stay the same, right? 2, 4, but the x becomes a negative. So if you replace x with negative x, you'll get the same thing, and that would be true here. More important, we call this an even function. Okay, anything symmetric about the y could be an even function if it's a function. So why I say that? Because you could have, I don't know, some weird graph that's not a function. Say you had a hyperbola, right? Even though it's symmetric about the y, it's still not a function. And the origin is symmetric about both. And we also have a special name for that. If it's a function, it's called odd. And that's where we are replacing both x and y, and we get to the original. So, oops. Let's take a look at these examples. All right. So discussing symmetry. First off, I want to point out, notice like all these powers are even. The one thing I am unsure of is what about the -1? But I'm going to show a separate test. Okay, we can look at symmetry as well. But a separate test says plug in x, make x negative, and if you get the complete opposite, it's called odd. If you get the same exact function, it's called even. And then we know symmetry. So we're kind of answering two questions in one here. So if I substituted a -x, then I would have this here and this here. I'm going to rewrite the rest back to black. So I'd have 5x squared plus 2x to the fourth minus 1. But -x squared is positive, and -x to the fourth is still positive. So notice we get right back to the original function, right? This is the same. So therefore, f of -x equals f of positive x, and this is an even function, which means it's symmetric. I'm just going to put symmetric, SYM, about the y-axis. Okay, I don't want to graph that thing. This is a quicker way to do that. So now, like, how do you know for sure it's not symmetric about the x, which would imply that it's symmetric about the origin if it is symmetric about both? So let's look at those other tests. So to check for the x, it says substitute -y for y. So f of x is y, right? That's another way to write y. So if I wrote -y there, and then I solved, right? I'm testing for symmetry about x. So I plugged in -y. Well, to see if it's the same as above, I would divide by this negative. So y equals -5x squared minus 2x plus 4. So that is not the same as the original, right? So that is a no. It is not symmetric about x. And to test the origin, we could do both. I could tell you now it won't work because the other rule, we'll go ahead and look at it on the second one. We will see what an odd function, which means it's symmetric about the origin, would look like. So if we plugged in -x and we arrived at the same function, we called that even. If I substitute -x and I arrive at a complete opposite, so all the signs changed, then it would actually be an odd function, which means it's symmetric about the origin. So what would that look like here? Well, each x I'm substituting -x, right? So I'm going to write that like that again. So I'd have -x plus 1 over -x, which that translates to -x, and then dividing by a negative, I could just move it out front, which means all these signs change, right? This was positive, now it's negative. This was positive, now it's negative. This is an odd function. That means that I plug in -x and I get opposite of what I started with. Okay, I get a negative f of x. All the signs changed. That's what that means. So sometimes a good hint, if we have an even function, we have even powers like we were saying over here, but then the constants you kind of have to question. Odds, often if you have odd powers, it's going to be an odd function, but the reason I don't like to teach that way at all is because what about this, right? Is that even or odd? Technically it is odd if you wrote it as x to the -1, but there are just too many functions out there. Okay, it's better to really understand what we're doing. So there is an odd function. Okay. So now if we wanted to test the others, we could for symmetry as well. I know it's symmetric about the origin because it's what we got. So let me show you another way to test for symmetry about the origin. Like say this is not a function, right? It still might have symmetry. So we talked about the other x and y, plug in negative y, plug in negative x. To test for origin, you do both. So instead of y, right, instead of y right here, I'm going to write negative y. And then anywhere there's an x, I'm going to put negative x. So equals, well, we had negative x, and then again we had divide by negative x, right? So plus 1 over negative x. Now, is this the same as the original? At first it doesn't really look like it, but if you divide by everything by negative 1 or multiply, right? I want to solve for y. So multiply everything by negative 1. I would have y equals positive x, and then this also becomes positive. It's the same as the original. So if you substitute both a negative x and a negative y, and you get the original relation or function in this case, then I know it's symmetric about the origin. One thing we didn't talk about, like, what does that look like? Symmetry about the origin is kind of a weird one, but if you picture y equals x to the third is an easy one to picture. So every point, you know, over here, let's say, it is symmetry about both axes. So we flip it about y and x. So first it kind of comes over here, right? Symmetry about y. And then it's symmetric about the x, so then it comes down there. And it doesn't matter the order. I could have went this way and then this way. Okay, it's a double flip. Each of these points would flip around both axes. All right, let's look at one more example. Again, because we have a function here, right, I'm going to use the f of negative x test. I'm just going to do it the short way. Instead of plugging in negative y, negative x, and then both, let's just start with this. So we would get, here would be a negative x, and here would be a negative x. So we have 7 negative x to the third plus 4 times negative x, subtract 2. Well, negative to the third is a negative, so we'd get negative 7x to the third. 4 times negative x is negative 4x, subtract 2. Notice it's not the same as above, right? F of negative x, all the signs are not the same, but it's not complete opposite either, because this is opposite, but this one stayed the same. They either all need to get right back to the original function to be even, or they all need to flip to be odd. Therefore, this is neither, it's not even or odd, neither even nor odd. So therefore, we know it's not symmetric about the y. We know it's not symmetric about the x. We still should test symmetry, about the origin. We still should test symmetry about the x-axis, though. But because this is a function, right, it tells me it's a function, I know it's not symmetric about the x because then it wouldn't be a function. Just to test it, let's see. So we do negative y. So, right, instead of f of x is y, I'm going to do negative y. And then equals 7x to the third plus 4x minus 2. Solve for y. Y equals negative 7x to the third minus 4x plus 2. And this is not the same as the original, so therefore it's not symmetric about x. Okay, be careful if you're doing the original test, like plugging in negative y, negative x, and then both. We're trying to see if we get back to the original equation. If you're testing for even or odd, then you're using the function rules, substitute negative x. and see if you get the opposite or the original, right? All these signs did change, but I wasn't doing the f of negative x test. I was testing symmetry about x.